Okay, so get this. We're diving into the world of AI, right? But not just any AI. We're talking about AI that's catching criminals, like actual criminals, at sea.
And we're not talking about like looking for messages in bottles here. This is high-tech stuff
Yeah.
using satellites, algorithms, all that.
Yeah, like imagine trying to hide on the ocean. You think you're home free, turn off your tracking, poof, gone. But not so fast.
The ocean's big, sure, but it's not invisible, and that's where this AI comes in. It can spot stuff even when someone's trying to like vanish.
We're talking about a new AI system and the research paper we're diving into today. It's all about this system and how it can detect, get this, vessels alongside.
Vessels alongside.
Yeah, sounds innocent, right? Like two ships just, I don't know, pulling up for a chat, maybe sharing some snacks.
Not quite. Out on the open ocean, two ships right next to each other, miles from anything. That's prime time for shady stuff.
Oh, okay, I see where you're going with this. Smuggling? Like things they definitely don't want the Coast Guard to see.
Exactly. Smuggling, trafficking, all sorts of things. And because they can switch off their tracking, those traditional methods, they're useless.
So this AI, it's finding a way around that.
It had to think about it. Spotting this tiny little blip of a ship from space, it's tough. This research team, they had to get seriously creative.
I read about this and it blew my mind. They trained this AI in two steps.
hmm
Like, first, they taught it to just recognize any ship in a satellite image.
Which makes sense when you think about it. You got to walk before you can run, right?
Yeah.
Or in this case, spot a ship before you can analyze what it's up to.
Right, got to lay that groundwork. And then they went in for the real detective work.
Exactly. But even recognizing a ship isn't always easy. These images from space, they're not always crystal clear.
Oh, right. Different satellites, different resolutions. It's not like taking a picture with your phone.
Exactly. So they used all sorts of data, Sentinel-2, Airbus Spot, different resolutions, different challenges for the AI.
Talk about a challenge. Did they have to create like different AI models for each type of image then?
They did. They had to train the AI to recognize ships in all sorts of conditions, different angles, different lighting, you name it.
That's crazy. And then on top of that, teaching it to recognize vessels alongside.
Hmm.
Didn't they run into a problem though? Like not enough real-world examples to learn from?
They did. I mean, how often do you find clearly labeled pictures of ships engaged in illicit activities?
Hmm.
It's not like there's a whole library of that just waiting around.
So what do they do? Do they just like give up?
Give up. Never. They got even more creative, if you can believe it. They started creating their own data.
Creating data, is that like allowed?
It's the future of AI. Think of it like this. They took real images of ships and then, using some seriously clever techniques, digitally placed them against various backgrounds, creating all these different scenarios.
So they basically built a virtual world of suspicious maritime activity.
That's one way to put it. And it worked. They were able to train the AI to a remarkable degree, even with the limited real-world data.
That's incredible. But the real question is, how accurate is it? Like, can it actually catch these guys in the act?
That's what we'll dive into next. And let me tell you, the results are pretty impressive. But we'll save that for next time.
So last time, we left off with this AI that's learning to spot suspicious activity at sea, specifically those vessels alongside.
And not just learning, but learning from data they created themselves. It's pretty wild.
Yeah, talk about thinking outside the box. But okay, let's get down to it. How accurate is this thing? Can it actually catch these criminals red-handed?
Well, the results are in, and let me tell you, they're pretty impressive. Remember how they used those Sentinel-2 images, the lower resolution ones?
Yeah, like trying to spot a suspect in a blurry security camera footage.
Exactly. But even with that limitation, the AI achieved an accuracy rate of over 90%.
90%.
Yeah.
Seriously. That's incredible. So even with those fuzzy images, it's still able to pick out those vessels up to no good?
It's a testament to how powerful these algorithms are getting. And it's crucial because in the real world, you don't always have those perfect high-definition images to work with.
So they're not just relying on crystal clear shots, which is good, because I imagine those are pretty rare when you're talking up vast stretches of open ocean.
Exactly. But they didn't stop there. They also tested the AI on those higher resolution Airbus Spot images.
And how to do? Just as good.
Even better. The accuracy rates for those were also close to 90%. But, and this is where it gets interesting, there was a bit of a hiccup with a certain type of ship.
A hiccup. Do tell. What kind of hiccup are we talking about?
Gas tankers. They proved to be a bit of a challenge for the AI.
Gas tankers. What's so special about gas tankers?
Well, they often have these large central pipeline structures on their decks, and the AI, in its quest to identify vessels alongside, sometimes mistook those structures for a second ship.
So it's like the AI saw a gas tanker and thought, hold on, are those two ships snuggled up next to each other?
Precisely. It's a good reminder that AI, as advanced as it is still learning. It's like teaching a kid to tell the difference between a dog and a wolf. There are those subtle nuances that take time to pick up on.
So even with these super sophisticated algorithms, there's still that margin for error for those, let's call them learning moments.
Exactly. But the good news is that the researchers are already aware of this gas tanker issue and are working on ways to refine the AI's training to help it better differentiate.
So they're like giving it an extra lesson on gas tanker anatomy.
Something like that. And it highlights the iterative nature of AI development. It's a constant process of refining and improving based on real-world results.
Okay, so a few gas tanker hiccups aside, the potential here is still huge. If it can be taught to recognize something as subtle as vessels alongside, just imagine what else this technology could be used for.
And that's exactly what we'll dive into next, the broader implications of this technology and how it could revolutionize maritime security as a whole.
It's really amazing when you think about it, right? We're talking about using AI to track down criminals on the open ocean. It's like something out of a movie.
It really is, and what's fascinating to me is that it's not just about catching the bad guys, it's about so much more than that.
Right. We've talked about illegal fishing, but there's also, like, the potential for search and rescue, right?
Absolutely. Imagine a ship goes missing. This AI could scan huge areas of the ocean so much faster than traditional methods, maybe find a debris field, a life raft, something.
It could be the difference between finding someone in time or, well,
Exactly. And it's not just about reacting to these situations, it's about preventing them in the first place. Imagine using this AI to monitor weather patterns, shipping routes, all in real time.
so we can prevent collisions, warn ships about dangerous conditions, keep things moving smoothly.
Exactly. It's about making the maritime world safer, more efficient.
And this is just the beginning, right? We're just scratching the surface of what AI can do in this field.
Absolutely. The potential is enormous. It's exciting to think about what the future holds.
Well, on that note, we'll leave you with this thought. If we can use AI to understand and protect something as vast and complex as our oceans, just imagine the possibilities for other global challenges. What other mysteries can we solve? What other patterns can we uncover?
It's an incredible time for discovery, that's for sure.
Thanks for joining us on this deep dive, everyone. Until next time.